Good morning. This is your stats sensei, Mr. Spensei, and this is a two sample T prompt, and it's the scenario "You're killing me," or "The wait time is killing me." Patients with stroke symptoms arrive at a medical center either by ambulance or by private transportation provided by themselves, family, or friends. Upon arrival, the time of arrival is recorded, as is the time diagnostic treatment begins. Okay, so the time between arrival and diagnostic treatment. A researcher wants to investigate whether the mean wait time for patients with stroke symptoms differs according to the mode of transportation. A random sample of 160 patients with stroke symptoms who had reported to the medical center was selected. For each patient, the mode of transportation and the wait times were recorded. Summary statistics for each mode of transportation are shown in the table below. And this really should say two random samples instead of a random sample, because we have a sample size of 85 and a random sample of size 75. All right, so this should say two random samples, so that needs to be corrected. Um, anyway, and here's our standard deviation, et cetera. So we're going to use that information, and I've already transferred that. So our formula, because it says run a hypothesis test to see if there's a difference. Is there a difference in wait time? And it's going to be really key that we pay attention to the word difference here, because that lets me know I'm working with a not equal or a two-tailed situation. So t equals x bar 1 minus x bar 2. Then we have s1 squared over n1 plus s2 squared over n2. And all I did was transfer the information from the table here. All right, so there's the information. I transferred it, good to go. All right, so let's go back to our graph. First off, it's two tail. So that means I need two tails here. And alpha is going to be in each tail. So in this case, not that they asked, but you need to know that the area in this tail is 0.025. And the area in this tail is also 0.025 because it's a two-tail test. All right. So when you go from one tail to two tails, alpha gets cut in half and p-value gets doubled. What are we centered on? Well, let me go ahead and skip down and I'm going to do my null hypothesis real quickly. The null hypothesis is that there is no difference. HO, mu1 equals mu2, or mu1 minus mu2 equals 0. So that tells me if there's no difference, that means I'm centered on 0. All right. My alternative is mu1 does not equal mu2, and that would be written as mu1 minus mu2 does not equal 0. Okay. So, and you need to be, it doesn't matter which way you write it. I prefer this way. I just think it's easier, the first one. But you need to be able to recognize it both ways because on a multiple choice, it may show up this way. So be able to recognize it both ways. So when we plug in, we're going to have t equals 7.12 minus 9.25 over 3.95 squared over 85 plus 4.72 squared over 75. All right. Inference procedure. Well, how many samples do we have? Well, we have a sample for the ambulance delivery and a sample for private delivery. So it's a two sample T test. All right. And it's really a two sample T test. If you have two sample T tests, you're going to be fine. But I want to say for the difference of means. Really, you just need to have this first part, two sample t-test. All right. Parameter. Well, we have two parameters because we have two different groups, two different samples. So let mu1 equal the true population mean wait time for ambulance transportation. All right. And I'm going to let mu2 equal the true population mean wait time for private transport. All right. Now, we can combine our conditions, and I'm going to kind of combine them here. So here we go. One, random sample of 85 given. The other one, random sample of 75 given. Here's where I'm going to combine. All right. Um, Now notice we have 160. All right. So I need to sit there and go, well, there's 85, but they did not give me a population size, which is kind of a problem. So we're going to take the 85 and multiply by 10. 85 times 10 equals 850. And we're going to have to say reasonable to assume that more than 850 use an ambulance. N is less than 10% of pop. All right, kind of a pain. Over here, we're going to do the same thing. 75 times 10 equals 750. Reasonable to assume that more than 750 use private. N is less than 10% of pop. All right, then normality. Well, normality is we have to be greater than 30, and both of these are greater than 30. So we're going to sit there and make a combine. Both N1 equals 85 and N2 equals 75 greater than 30. And I'm running out of room, but the distribution of means is approximately normal by CLT. Don't abbreviate normally, but we're short on space. You won't be on a test because you'll have plenty of room. Also, on a test, after you've written this down, you probably want to cross it out because if it's wrong, if you have anything wrong there, they count off. And the same with this. This is for you. All right. Mark it out. Okay. Probability. All right. So my probability statement. Remember, this is a two-tailed test, so we're going to have to go 2 times the probability that t, let's go ahead and run the test. All right, stat edit, stat test, drop down to 2 samples t-test, number 4. And I've already input the table information into the calculator. That's also the information I wrote up here. All right, so 2 sample t-test, and I have that information. I'm going to go ahead and, oh, and by the way, we never pool. Make sure not equal is highlighted, and I'll show you why in just a moment. Calculate, and I get a negative 3.0724. Probability that 2 times the probability that t is less than negative 3.0724 equals 0.0025. So my p-value is 0.0025. My alpha is 0.05. That was given to me at the top of the paper. This is less. Our decision is to reject the null. All right. So first off, this less than. If it's negative, use less than. If it's positive, use greater than if you're working with a not equal to. If you're working with a not equal to, if it's negative, use less than. If it's positive, use a greater than. So the reason this is important to make sure that we had not equal test checked. Our p-value is 0.0025. I'm going to rerun this same thing with a 2 sample t-test, but I'm going to use a less than. And you'll notice our p-value is half. So if you go from one tail to two tail, your p-value doubles. All right, one tail to two tail, alpha gets cut in half. One tail to two tail, p-value doubles. All right, so what are we going to say? Our p-value is 0.0025, which is less than our alpha equal to 0.05. And by the way, you can write it out in words if you prefer. What's our decision? We reject the null. There is sufficient, or there's enough evidence to suggest that the difference of the means, I need to talk to you about that for just a second. In wait time. So difference of the means. All right, if this is paired, it's mean of the difference. Difference of the mean is because, oh, we subtracted 2 means. And remember, difference, subtract means difference. So the difference of the means. Whereas in paired, we averaged we took the differences and we averaged them. So it was the average of the differences. This is when we subtract the 2 means, is the difference of the means in wait time. And we had to put our order, and we went ambulance minus private is, what's our alternative? Not equal to is different. Or is different, or is not the same. All right. So that's our hypothesis test for the wait time. The wait is killing me. Hope that helped. Look forward to seeing you on the next one. Thank you.